Let's calculate this indefinite integral, the indefinite integral of 30x times 3x squared plus 7 to the power of 4. So in this example, again, I could maybe actually multiply 3x squared plus 7 times itself 4 times and expand that all out and use some simpler indefinite integral laws. But that's a lot of work, so what I'm going to do is I'm going to use the u substitution method. So as always, to do the u substitution method, the first thing that you want to do is you want to figure out what you should be substituting for. What should u actually be equal that will make your life easier? So we have a few choices here. We might choose u to be 30x. We might choose u to be 3x squared plus 7. We might choose u to be 3x squared plus 7 all to the power of 4. We could choose u to be the entire integrand. What ends up working for us in this question is u equals 3x squared plus 7. And the reason this will end up working out quite well for us is if you look at the derivative of u, what you end up with is 15x. And 15x is just a constant multiple of what's actually sticking out front here. So this is actually going to allow us to do some nice cancellation. So this u is the one that's going to work out for us. Now, if you're new to substitution, that might not have been your choice, and I encourage you to try other versions of u. And a lot of times it just takes a lot of practice in order to kind of get a feeling for what u you should be choosing. So anyway, with this version of u, what I'm going to do is I'm going to rewrite our indefinite integral in terms of u. So this is 3x squared plus 7 to the power of 4 dx. And now all I'm going to do, without doing any other calculus, I'm just going to actually put in what the u actually is standing in for. So this is 30x, and then now I have u to the power of 4 dx. So all I've done here is I've taken this 3x squared plus 7, and I've replaced it by its nickname, u. So now we have an indefinite integral, and we've kind of run into a problem here. The problem is that we have a function that is supposed to be being integrated with respect to x, but inside this integrand we actually have a variable x and we have a variable u. So we can't really carry out this indefinite integral until we get everything in terms of the same variable. Over here was all in terms of x, which is much more complicated for us. So it's probably a good idea if we try to actually get everything in terms of u. So to do that, what we're going to do is we're going to try to get rid of this dx as well as this x here. So a usual typical second step in doing a u substitution is to isolate for dx or solve for dx. Now, of course, this isn't quite mathematically correct, as du by dx is not a fraction, and in some sense solving for dx isn't quite correct, but it ends up doing the job for us and giving us the right answer. So what I'm going to do is I'm going to take the derivative of u with respect to x, which in this case is 6x. And then I'm going to solve this equation, assuming this is a fraction, which it is not. Again, it just happens to work out well when we're doing substitution. So one can think of this as a fraction and isolate for dx. So we get du is equal to 6x dx. And then again, what we want to do is we want to isolate the dx. We want to solve for the dx. So I'm just going to write dx by itself, and this is 1 over 6x du. So now wherever I see in my question a dx, I can replace it by 1 over 6x du. So I'm going to just rewrite this as 30x u to the power of 4. And now that I have this dx here, I can replace it by 1 over 6x du. So now I have 30x u to the power of 4, multiplying this fraction here, 1 over 6x times du. And of course I can cancel this x out with this. And 30 divided by 6 is actually 5, so this actually simplifies to 5u to the power of 4 du. And because of my integration laws, I can actually remove this constant and put it out front. So this becomes 5 times the integral of u to the power of 4 du. And now I have a nice integration where I'm integrating with respect to u, and my function that I'm integrating is a function of u. So now I can actually use the formulas and the laws that I have for anti-differentiation and actually anti-differentiate this. So the rule with this a variable to the power is to increase the power by 1. So this becomes u to the 5. So 4 plus 1 is 5. And then what you do is you multiply by 1 over the new exponent. So 1 over 5. And then I can add the constant, the arbitrary constant in as well. So I can actually clean this up a little bit now. I can multiply everything by the 5 here. 5 times 1/5 is just, the 5's cancel and it just gives me 1. So this becomes u to the power of 5 plus 5c. And then I can put back in what actually u was. So u was 3x squared plus 7. So now I can replace the u with 3x squared plus 7. That's the power of 5 because u here was the power of 5, and this is actually what u is equal to. And then this constant here, it's the number 5 times some arbitrary constant. Of course, that just gives me some other arbitrary constant. I can call it d. Again, many textbooks call this c. They just leave it as c. But just for clarity, I'm gonna rename it some other constant. I'm going to call it d. And this is our final answer.